Hi, today I would like to talk to you about mathematical proofs. A mathematical proof is in general a series of logical steps that we write down to show that one side of a mathematical statement or a mathematical equation, like the one you see here, is equivalent to the other side for all the values of the variable if there is a variable in the equation. As you can see here, the first example, it's rather easy. In fact, it's easy to check that the left-hand side is equal to the right-hand side. You know very well that if you have a common denominator here, this is going to give you a 3, here there's going to be a 1, this is going to be 4 divided by 12, and this is going to give you 1 over 3. What I did, in fact, was taking the left-hand side and turn this left-hand side into the right-hand side. I'm done with my proof somehow, so I can write left-hand side, 3 lines, right-hand side. I can also write at the end of the proof QED, which means quod erat demonstrandum, which means what was demonstrating. Maybe you met it before. But I can do the same, okay? Actually, I can expand the result that I had here in this numerical example to a more algebraic example here on the right. So as you can see, I have two fractions here. I have a left-hand side, right? This is my left-hand side. And this is my right-hand side. And one rule that I have to follow is that I cannot move stuff around when I do a proof, okay? So what I'm gonna try to demonstrate is that the left-hand side now here, it's equivalent to the right-hand side. What I'm gonna do is to create a common denominator. You see here that actually this fraction can be written as 1 over m times m plus 1. So I can actually use this denominator as the common denominator, because m plus 1 is already in this term over here, but then I need to add m here, and then I will have m plus 1. So I'm taking the left-hand side now. I rewrote the left-hand side in this way, and now I can see actually that the factor that it's appearing in the numerator, it's actually also in the denominator, and so I'm proving that this is actually equal to 1 over m. Remembering also that I can do this operation only if m is different from 0 and m plus 1 is different from 0. And this is because in the denominator I have this factor m and this factor, and they cannot be 0, okay? Otherwise the fraction doesn't exist, better it explodes, right? But what I did here was just a more general example of proving that the left-hand side is equal to the right-hand side. I could now use this proof to actually verify this equation for a particular m. For instance, if m is equal to 3, I can now use this relation that I found, which I rewrite here for the sake of it. And I can prove to you that this is valid for m equal 3. So here I'm going to have 1 divided by 4. Here I'm going to have 1 over 9 plus 3, so 1 divided by 12. And here I'm going to have 1 divided by 3. And as we proved before, this is actually true for m equal 3. We can actually prove that this is equal also for m equal 1, for instance. So I'm going to have 1 divided by 1 plus 1, so 2, plus 1 divided by 1 squared, it's 1, plus 1, again, it's 2, and this is equal to 1 over 1, which is just 1. And this is actually true, you see it already, so the left-hand side is actually equal to the right-hand side. So it seems that this equation, it's really a generalization of what we saw over here in a numerical example. And this is actually super useful to see that it's working in some cases, because right now what we could write actually, it's something that looks like that. So we write, instead of writing equal to, we could use another symbol that we have to learn a little bit what it means. And it's an equal, but it's a special equality. These 3 lines indicate an identity. What is an identity? Well, an identity is a statement that it's valid for every m belonging to a certain range of numbers. For instance, in this case, it could be the integer numbers. Okay, so it's valid for every n. This symbol means every. So remember that there is a fundamental difference between equal and the identity sign. The identity sign, it means that if you have a variable like m in this case, it's valid for every n. The equal sign, it doesn't mean that. It could be even an equation, for instance. Let me write it over here. X plus 2 equal 3. Well, this is valid only if x is equal to 3 minus 2. So if x is equal to 1. So this is an equation. We are solving the equation and we find that this particular statement is true only for x equal 1. But this expression here, it's actually valid for any integer m. So just to recap, this is called an equality, and this is called an identity.